Okay, so chapter 4 on data visualization. So this presentation is on data visualization. We'll cover homework 4. Data visualizations are usually pretty popular with the students, and with good reason, because it makes it easy to see the results of the analysis. Data visualizations, though, tend to be more on the descriptive analytics side, so um, it's good to be able to do data visualizations, but the higher paying jobs are going to want you to do kind of the stuff we're going to learn in the future and more of the predictive or prescriptive analytics models. But when you go into presenting your analysis, you're still going to need to have the data visualization skills. Um, and while they are not the best product that analytics can produce, knowledge of visualizations can help support your analytical findings. So data is great, but if it doesn't provide insight to create value for the information, then it doesn't have any value, right? It's kind of the difference between data and information. Raw data doesn't have any meaning, but once we add meaning to that data, then we have information. So one way to demonstrate the value of data to managers is using data visualizations. Visualizations improve communication of results by making them easily understood by anyone. Data analysis allows companies to make sound decisions, and visualizations improve that process by making it easier to see the results and trends. So this visualization provides some examples of well-displayed results, except maybe the one in the top left that doesn't have a key. The goal is that they are easy to understand and see, and to accomplish that, there are many guidelines that should be followed when creating visualizations. We will go over some of that in this presentation. All of the visualizations in this presentation were created in Tableau, not by me. So which is the most popular tool for data visualizations and for, if you're going into an analyst job, you'll definitely need to know Tableau and how to create data visualizations. And I think we have a separate class on that, but we'll touch on it just a little bit in this class. So principles of design. To understand the guidelines of data visualization, we first have to define some terms. Balance is how the objects are distributed in space and can be symmetrical, asymmetrical, or radial. Emphasis is the visualization attracts the viewer's attention. Proportion is the size of each thing in the visualization. And rhythm is the transition between the design elements. Variety is the type of visualization being presented, promotes engagement and prevents the viewer from losing attention. And unity is what pulls all of these design elements together. So these are just, basic terms probably associated with homework question. So basic elements of design. There are 7 basic design elements in data visualization. The color selection determines how the viewer feels about what they are seeing. You may have heard this in similar aspects of like ties. If you're going to an interview, wearing a red tie is like a power tie. And if you wear a blue tie, it means you're cool and relaxed. But you can see how, color affects how people feel. Form refers to the lines, shadows, length, width, and depth used in the design. Line is the path of the line in the visualization. Shape can be geometric, organic, or abstract, but for obvious reasons, geometric shapes are the most common in data visualization. Both positive and negative use of space can also convey a message, and the texture of the design adds a touch sensation to the design. Typography is an easy element to address as it refers to the text itself. So these are just, more key terms about how to design good data visualizations. But like I said, I have a whole class using Tableau and these kind of design aspects. We won't cover too much of it in this class. So, examples of balance and color perception. In this image, you can see the design principles being used. The bottom design indicates the way different colors make people feel, and the selection of color is very important because of this. So, like I was saying with red, it's kind of a dangerous color to utilize because it generally means it's negative or aggressive. That's why, you have the red stoplight. Maybe that's why it gets denoted that way. Yellows tend to be warm, and then usually greens and blues, maybe some purples, tend to be better, provide better feelings based on color. So some common types of charts and graphs, you have the time series. Over the next slide, we'll look at several different data visualizations. But here we have time series, which shows how values move over time, and often used to track, stock prices, for example, over time, or number of sales over time. Generally, you're going to have, one axis or axes is going to be time, and the other one is going to be kind of what you're measuring over time. So line, it makes it easy for people to follow a trend, right? Or you could utilize fitting for some kind of time series regression. Rankings are used to see results by importance, preference, or achievement. The use of columns or bar charts can be used to show how items rank next to one another. So it's very easy to look at this chart quickly and say, oh, chemicals is making the most money for exports, and textiles is making the least. So maybe we should focus on the chemicals aspect of our business or something like that. So part to whole. So it's like I don't know, I don't remember what the terminology is, like bifurcated bar graph. I don't know. So part to whole shows categories in terms of fractions or ratios and are often shown as percentages. Displaying them as a stacked bar chart is often an effective way of displaying this type of result. So we're looking at the best-selling car colors. You can see that number 1 is the highest at 36.8%, and yellow obviously is the lowest at 0.9. It's kind of funny. I've never had a blue car. I've had, I guess you could call them red. Never had brown. Gold, I'm surprised. Who would drive a gold car? But yellow, I had a yellow truck and everybody made fun of me for it. But I only had the yellow truck because it was super cheap. Probably because it's such an unpopular color. Yeah, common types of charts and graphs. Correlation. So correlation shows the relationship between numerical variables and is often displayed using a scatter plot. We'll talk more about correlation in future, and we'll make some cool visualizations that I think are probably a little more useful than the one displayed. But living square foot of living area to price, I mean, should be pretty obvious that the bigger something is, the more it's going to cost. Frequency distributions show how many instances occur in the interval without the bars touching. When the bars are depicted touching, it is a histogram. We also, when we look at when we start talking about descriptive statistics and how the underlying distribution is formed, we can see something like this it's got some skew to it, so it's not going to be normally distributed. There's a lot we can pull from this kind of display of data when we get into the assumptions that are necessary for running an algorithm, and potentially if we need to, if something's exponentially distributed, we might have to transform it. We talked a little bit about in a previous chapter about sometimes you have to transform data before you can put it into an algorithm. But seeing something like this, that's kind of the first thing that I think of. Oh, we may need to do something to make this data useful before we put it into an algorithm. Box plot can also be used to look at distributions and subgroups. Box plots allow the variables with greatest impact to be identified. So honestly, not one that I use super frequent. Basically, a box plot just displays, outliers. You have your min and your max. You have quartiles, your mean, median, etc., all on one box and whisker box plot. Generally, I'd rather just look at the numbers than see it visually, but some people like box plots. Geospatial maps, geographic results can be compared using maps and can be very effective. None of the research or kind of analysis I use tends to use geospatial data, but I assume it's useful if you're in that kind of field. Especially, I mean, if you're looking at, how the COVID pandemic was spreading out or something like that. Deviation analysis shows changes when compared to something else. It's good to use to show the difference between forecasted and actual sales. So I think in this example, it's looking at two different companies, Lyft and Uber, and their net income. Seems like Lyft has been a bit more gradual. Don't know why they're pointed downwards. I don't know if in 2018 it looks like they peaked in their usage of car rentals this way, or basically like using a taxi, but you can call it using your phone or an app. I mean, I don't know. I assume Uber and Lyft are more useful in bigger cities, and it's not something I use frequently. Nominal comparisons display quantitative results in subcategories, but not in a specific order and not sharing relationships. It is simple, but can be effective if these are the types of results you're displaying. If you're looking at, different product sales, I think this is just a kind of a basic bar graph and display. Looks like detergent is what is being sold the most of. Battery is second. That's just kind of the quick glance pulls you can do. So what's your story? The most important part of creating data visualizations is to know what story your results are providing and using the appropriate visualizations to tell that story. The questions you can ask to determine this is to know what data is available, who the visualizations are intended for, and what results are expected, and what type of chart, including the design principles, best displays those results. This is the most important thing to keep in mind to ensure your results are clearly communicated. Okay, so this is the end of the presentation on data visualization. We'll do more like applied, active use of data visualization in class, but this is the lecture that corresponds to homework 4.